Hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. So today, I'm going to talk about this question, number 6, on the non-calculator portion of SAT practice test number 9. And this little trick is going to be a lifesaver on those geometry problems where you don't know what the heck you're supposed to do. All right, so before we get started, if you've taken a close look at this circle, it might look a little skewed. That's just because of the camera angle. I'm actually using my laptop to kind of just shoot this video. That way it's like a stable thing instead of using a phone kickstand or whatever, because I don't really do kickstands. But anyways, so this circle was drawn by a compass. It's completely circular, but since of the camera angle, it looks a little off. But just go with it. So this is number 6, like I said, and we're going to look at how to solve it algebraically. But before we do that, I'm actually just going to measure it. Just going to measure what's going on here, and we'll figure out the answer that way. Okay, so first let's figure out what they want. Circle above us, center O. Length of arc ADC is 5 pi. Length of arc ADC is 5 pi. Okay. And x is 100, right? So they didn't put that in the picture. 100, right? What is the length of arc ABC? Okay, so they want this thing right here. Okay, well, in order to find out what that is, let's measure it. Okay, so I'm actually just going to move this over a little bit here. And then I'm going to use a 3x5, but obviously, you're not going to use 3x5s on the SAT. So what you would do is just use the side of your paper that you have for scratch paper. Okay, they're going to give you some scratch paper, so use that. And I'm gonna measure this. So you could curve it if you really wanted to. You could go like this and try to curve the paper. But that's a lot of work, and you don't need to do that, right? So instead of trying to do a curve, well, it's related to AC. The arc that goes from A to C is similar to the arc that goes from the segment that goes from A to C. So why don't we just start there? Put a little tick mark right there. And now we know that's basically the equivalent of 5 pi, right? It's obviously a little less, but we'll just say that's kind of like 5 pi. So what we do then is we line this up over here and figure out just how many of those distances would we have to go from A to B to C. Well, let's see. It looks like right here is 1. So I'll put a little mark right there. And then let's start at this mark again. So from here to here is 5 pi. Right, so this is a 5 pi marker. And then it looks like from here to here is another 5 pi. So I'll put another little marker right there. So it's going to be more than 10 pi. All right, so it's definitely more than 10, so it's not 9. 13 over 2 is less than 10. But I wouldn't say it's 18. 18 would be another 5 pi and then some. Right, so if I go another 5 pi, I'm actually all the way back around to D. And that would be 15 pi, so it's not 18 either. Which means it has to be B. Right? There's nothing that was even close to that. So the answer is definitely B. There wasn't even an answer close to it. I don't have to actually even do the math for this. I can just say it's B and then kind of just move on to the next problem. Okay, now this method works if you measure it well, so be precise, precision matters. If the question says it's not drawn to scale, then maybe it's not actually drawn to scale. There's a possibility it actually still is. I know it's weird, it seems like they're lying to you, but sometimes they'll say it's not drawn to scale, and it actually is, and this trick does work on problems like that, but definitely a yellow flag, and I wouldn't bank on it, on this method working if it says that it's not drawn to scale. So be careful when it does that. But otherwise, that's it. We solved it. The answer is B. Now let's show this algebraically. So what's happening here is I have 100 degrees, and somehow 100 degrees translates to 5 pi for an arc. And since all the answers have pi in them, let's just go ahead and get rid of this. Just get rid of the pi. All the answers have pi in them. So 100 degrees translates to 5. Okay, so that means whatever the degrees are, it seems like if you divide by 20, you get the length of the arc. Right? 100 divided by 20. So we just have to figure out how many degrees are in this other thing over here. Right? Well, that's actually not too bad. I mean, the whole circle is 360, right? So that means this must be 260. Right? 260 plus 100. So 260. Well, that's going to do the same thing. Whatever the angle is, it seems like if you divide by 20, that should give you the other side. And the reason why I know this is because it's proportional. The circle is proportional. I'm not going to show you the long method on here because I don't want the video to be too long. But basically, pretty much everything to do with circles is proportional. So if I want to get from degrees to the arc length, it looks like I divide by 20. So I'm going to divide this by 20. Divided by 20. And zeros will cancel. 26 over 2 is 13. So yes, it is B, 13 pi. Done and done. That is it for today. Short video. Hope this was helpful. If it is, like, subscribe, all that stuff. By the way, I have a free guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's on my website, myersmathematics.com. And here it is, Myers. Almost forgot how to spell my name right. Mathematics.com. That's where you can find my free guide, The 5 Math Mistakes Everyone Makes and How to Avoid Them.